Oh, there was no countdown that time. All right, self-check 4.2 for AP calculus AP. Let F be a function where you have that, and we're satisfying the mean value theorem. All right, so again, we're doing this F prime of C. Just the definition of mean value theorem is equal to F of B minus F of A all over B minus A. We have our A is 0, our B is 3. We need our F prime. Let's do that now. F prime of X is going to be equal to 3x squared minus 6x. Therefore, F prime of C is going to be equal to 3c squared minus 6c. Let's do F of B. F of B is the same thing as F of 3 in this case. This is going to be equal to 3 cubed minus 3 times 3 squared. It's going to be equal to 27 minus 27, which is equal to 0. Oh, we get a lot of zeros here. And F of A is equal to F of 0, which is equal to 0 cubed minus 3 times 0 squared, which is equal to 0 minus 0, which is 0. So plugging in everything to this formula, so all of this is going to come out here. Or maybe I can move here. You go off to the side. That's all of our scratch work. We have 3c squared minus 6c is equal to 0 minus 0 all over 3 minus 0. Therefore, 3c squared minus 6c is equal to 0. Factoring is going to give us a 3c factored out and a c minus 2 on the inside. That's going to be equal to 0. And in this case, we have c is equal to 0 and c is equal to 2. Solving for each of those using the zero product property. I don't see a 0 and 2 option. And again, mean value theorem is talking about the derivative. It's usually not true at endpoints, so I'm going to choose B for 2 only.
I'm guessing B is
So 0, while it is in the interval, you might be thinking 0 only. 0's at the end, and I'm pretty sure that means that we don't have 0. Although I should clarify that with John. Yeah.
So it says in the closed interval 0 and 3, which means it can't be 0 and it can't be 3.
Yes.
So you could just cross out A, C, D, and E, right?
I believe so, yeah.
That's what I did to guess.
That's interesting. Yeah, I really need to ask John about this question because that's super duper interesting. Yeah, I don't know the answer to that, but I think just by knowing that one rule, you probably can get B by itself. Interesting. So I just said, well, you know, explain again.
So because it says a closed interval with the brackets 0 and 3, which means it can't be 0 and it can't be 3. So you can just eliminate A, C, D, and E. And you're just okay.
That's very smart.
I think that's really true. Yeah. Number 2, we have the radius of a circle is increasing. So increasing is one of these positive words. And at a rate of 0.2, so our prime here is going to be a positive 0.2. Rate of increase of the area, so we're looking for an A prime in this case. At the instant for the circumference, so C is equal to 20 pi. All right, so we have A prime, might as well write down the equation for A prime. A prime in this case is equal to 2 pi r prime, and we need circumference as well. The formula for circumference is 2 pi r. Let's fill in what we got. Down here in terms of circumference, I've got circumference is equal to, I know that circumference is 20 pi, so I can say 20 pi here is equal to, is equal to 2 pi r. Let's go ahead and divide both sides by 2 pi, divide by 2 pi, and again, r is equal to 10. And let's plug in everything to A prime. A prime in this case is equal to 2 pi. What's r? We have 10. We just found that. And r prime came up here from the problem is 0.2. I can say 0.2. And multiplying those together, 0.2 times 10 is 2. 2 times 2 is 4. So I get area prime here is equal to 4 pi. Correct answer here is C.
Would you say 10 times 0.2 is?
10 times 0.2 is 2. Again, the decimal, whenever you multiply by 10, it moves the decimal place 1 to the right. If I multiply by 100, the number of zeros is the number of places that I move to the right. So, what I'm like, let me give you a random example. 13.467. If I multiply that by 10, what's going to happen here is this decimal place will move 1 to the right.
Yeah, so, okay. So 4 times 0.2 is 10. Wait, so because you said 10 times 0.2 is
2.
Oh, it's 2.
Because again, this is 0.2, but if I move the decimal over, it turns into just
Okay,
2.
now I got it. Okay, now I got it.
And then 2 times 2 is 4. There you go. You're good. All right. Moving on to number 3. The radius of a sphere is decreasing. Okay, we got a negative word here. This is a negative word at a rate of 2 centimeters per second. So r prime in this case is equal to a negative 2. At the instance when the radius of the sphere is 3, so in this case r is equal to 3, we're looking for the rate of change and gives us the units for surface area. So we're looking for surface area. Here. Surface area prime is equal to what? And tells us an equation for surface area. Might as well take its derivative since we're trying to find s prime and we only have s. So we are going to say s prime in this case is equal to 8 pi r prime. All right, let's just fill in what we've got because we might be done. I think we are. So if I say s prime in this case is equal to 8 pi, r in this case is 3, so plug in 3, and r prime in this case is negative 2. And I am indeed done. I just have to multiply these together. So 8 times 3 is 24, 24 times 2 is 48, and then we need to make that negative 48. So I get s prime in this case is equal to negative 48 pi. And they didn't try to trick you and put a positive 48 pi, but the correct answer here is C. That was a nice little easy one. And then number 4. We've got a ladder. That means it's a right triangle. Let's go ahead and make our right triangle. Point, point, point. And okay. And it doesn't use any letters, so I'm going to use A and A prime, B and B prime, and C and C prime. Got to find all of these. So it's a 25-foot ladder, which means C is 25. C prime probably is 0 because the ladder doesn't change size. It's sliding down at 3, so I'm going to say A prime is negative 3. Down is my negative direction. And the top of the ladder is 7 feet from the ground, which means A is 7. And we're looking for the rate of change for B prime. So B prime is what we're looking for. The only thing that we have left to solve before we find B prime is B. And to do that, we're going to use this secondary triangle over here. So second little triangle over here. And we're going to ignore the primes for a second. I have 25, I have 7, and I have B. You might remember this one from the homework. This was a 7, 24, 25. If you don't remember that from the homework, then you can rewrite it again, which is coming from A squared plus B squared is equal to C squared, where you have 7 squared plus B squared is equal to 25 squared. 25 squared is 625. 7 squared is 49. And if I subtract 49, I get B squared is equal to 576. And if I square root that, I'm going to get that to be 24. So B is equal to 24. If you didn't know the square root of 576, you can do guess and check. Yeah.
So the one question I always have on these ones is how do I know what the variable is? Like, because I put A instead of B.
Yeah, that's fine. I mean,
But
none of these.
Wouldn't that eventually matter because it's like I'm looking for the prime and I have the wrong variable? I feel like that's kind of affected.
No, because again, if I just switch my B's and my A's, it's going to switch this order. It doesn't matter if I do 1 plus 2 or 2 plus 1. The order of adding never matters.
Okay.
So you're good. Yeah. So B is 24. We can come back here and say, okay, found our 24. And then I can plug into this A prime plus B prime is equal to C prime. We have 7 times negative 3 plus, and then there's the 24 that we just solved for. 24 times the B prime that we don't know, and that's equal to 25 times 0. All right, so it's going to be negative 21 plus 24 B prime is equal to 0. Adding 21 on both sides gives us 24 B prime is equal to 21. Dividing both sides by 24 gives us B prime is equal to 21 and 24. We can reduce that because the top and bottom are both divisible by 3. So if I do that, I'm going to get a 7 over 8, and that is a positive 7 over 8. And there is a negative 7 over 8, just in case you want to make a sign error. The correct answer here was D. And it makes sense, right? If I am sliding down the wall, I should be sliding away from the wall as well. Away from the wall is a positive. Towards the wall is a negative. All right. And that is what we're doing for the day. We have a good almost 9 minutes left over. How are you guys feeling about that entire self-check?
That was not that bad.
I can do it. I just need more time.
Okay, no, that's good. If you just practice more and more and more, you'll get faster and faster and faster, right?
I just memorized this one from the homework, except I got the sign wrong.
Oh man. All right. How many did you guys get out of 4? Oh my God, the bar has been raised yet again. All right. So
Yeah,
tomorrow,
that's
I'm
a
expecting
good
at
guess.
least. I don't know what does tomorrow have. Tomorrow has 5 questions, so I'm expecting to get at least 3 out of the 5, right? Again, these self-checks get progressively harder and harder as we're working our way through the curriculum. So
I think I just